Hello everyone, I am Yu Chong Hao. I am the presenter today for the topic Performance Analysis of Deep Learning Neural Network for Object Classification with Edge TPU. This is the content that I will present today. For the introduction of Edge TPU, Google Edge TPU is a recently released application-specific integrated chip built-in on Chorus products that provides a platform for developers to run their deep neural network model on edge device, decreasing latency and minimizing inferencing times of an AI running on small form factor device. It is designed for running machine learning algorithm released by Google in the early 2019. It is based on the TPU that Google offers on their cloud service in order to run machine learning algorithm, but much more simple. A powerful chip for any kind of edge device that need to run any machine learning application. The main objective of this work is first benchmark the performance of various deep neural network model on selected edge device with and without the Edge TPU. Second, benchmark the performance of Tensorflow Lite machine learning library and the Edge TPU API library that allow the use of Edge TPU hardware when running machine learning algorithm. This is the overview of the architecture for deep learning inference with edge computing. There are 5 types of architecture for edge computing. For the common one is on-device computation. The other will related with the edge server to distribute the computing with the end order. For the methodology, they have 3 steps to complete the performance analysis. First, we will procure the testing data set. We create the application to download thousands of images, and then we sort the image into usable testing data set for this analysis. Second is benchmarking with test image. We create an application program to automate the benchmarking process with test image. In this test, there are 2 different applications, one using Tensorflow Lite library and another one is using Edge TPU API. Third is a benchmarking with camera. Similar with the second stage, we also create an application to benchmark the performance of the neural network model with a camera. These are the hardware used for testing. There are 4 types of edge devices are used, which are Raspberry Pi version 4, version 3, and Intel NUC. These are all the hardware specifications for the edge device used in this testing. For the deep neural network model used in this testing, there are 5 types of different neural network, which are MobileNet version 1, MobileNet version 2, EfficientNet S, Inception version 1, Inception version 4. However, the architecture of this neural network will not further discuss in this presentation, but for more information, there are the reference paper can be read for more info. This is the program flowchart of benchmarking application with test image or camera frame. In the end, the average inference times, accuracy, and frame per second FPS for camera will record and further discuss. This is the result for benchmarking with test image. By using Edge TPU API and Tensorflow Lite library, we found that the average inference time is more faster if we use Edge TPU compared with CPU. This is the result for benchmarking with camera. Similar with the benchmarking with test image, the average inference time is more faster if compared the Edge TPU with CPU. So it is more faster if we use Edge TPU. The result also show in graph, and we brought the benchmarking with the accuracy versus inference time. So it is more clear for the accuracy, and we found that the mobile net version 2 is more higher if we use the similar dataset. The inference time also considered fast. For the benchmarking with camera, we brought in graph the average FPS versus average inference time is brought. From the graph, we can conclude that the inference time will faster if we use HTPU if compared with CPU. For the performance, HTPU is more faster compared with CPU. From the hardware testing, we found that Intel NUC is more faster if we compare the inference time, and the result also show the comparing inference time on Intel NUC with using different neural network model, and also the result for accuracy. So for the conclusions, we can state that more powerful edge devices are needed to enhance the computation on site, rather than wait for data on or result of DNN transferring from a centralized server hosting. By utilizing the Edge TPU hardware developed by the Google, a relatively low-cost machine learning computation chip compared to the big hardware like GPU and Cloud TPU that can run a quantized DNN at a very fast speed depending on the hardware and DNN model. Additionally, edge devices used in this work show outstanding performance, especially the newly released Raspberry Pi 4B, which can be bought in cheap, and the Intel NUC i7, which is very compact size and offer the performance as similar as a personal computer. Both of these devices are suitable options for edge computing with DNN model depending on the application needed. It is also important to note that the quality of equipment used alongside any DNN application will affect the performance of the DNN application. This work was funded by the Yayasan Chancellor Unit 10, and the author would like to acknowledge our research collaborator Isote Serma for their contribution, expertise, and equipment. That's all for my presentation. Thank you.